Good morning Year 10. Please complete your do now in your exercise books. Pause the video while you do this. Now I'm going to show you the answers for the do now questions. Make sure you tick off your answers and correct any that need correcting. We will be using this information this lesson. Have a 30-second think about what all of these objects have in common. Pause the video to do so. All of these objects are made of different alloys. Alloys are mixtures of metals, and we will be learning about them today. So, your title for today's lesson is Alloys. Here are some common types of alloys that you have probably heard of. We have steel, though there are many different types of steel. We have bronze, which is a combination of copper and tin. And we have brass, which is a combination of copper and zinc. We also have solder, which is an alloy of tin and is commonly used in electronics. And lots of your parents' cars may have alloy wheels, and they are alloys of either aluminium or magnesium. Historically, precious metals were alloyed to deceive buyers into thinking they were worth more. There is a relatively famous anecdote about Archimedes. He was asked by King Herod to check whether his crown was pure gold or not because he thought a trader had tried to deceive him. This is when Archimedes weighed both of a crown and some gold, and then he measured their density by looking at the volume, because it's the famous scenario where he sat in the bathtub and realised that the same amount of water was displaced out of the bath as was his volume. So he was able to do this with the crown. That gave him a volume for the crown. He could measure the mass, and therefore he could work out the density and see if this matched the density of gold. So, what are alloys? Alloys are mixtures of metal atoms. They are most commonly alloyed with another metal. And we do use alloys an awful lot in today's society, and it's because of the more desirable properties they have rather than a pure metal. Make sure you make some notes on what an alloy is. This doesn't need to be much, just a sentence or two. Now we are going to look at a video on the properties of alloys.
In this video, we see how different metals bond together to form alloys, which still retain the metallic properties of the starting metals, but are usually stronger. Metal atoms are typified by having only a few electrons in their outer shells. This means that even when they bond, there's always room in this valence shell for more electrons. Each metal atom can bond with up to 12 others in a close packed lattice. Look at the red atom. It is surrounded by 6 in its plane, and 3 on top and 3 underneath. Less compact crystal structures are possible too, for example this arrangement where each atom is bonded to 8 others. Because there are still not enough electrons to complete the outer shell of any of the atoms, the electrons can move easily from one atom to another, making metals good conductors of both electricity and heat. And because the electrons are not localized in fixed bonds, the atoms can slide past each other, making them ductile, allowing the metal to change shape. It also means that when you try to react metals together, the atoms normally just mix into the lattice, forming metallic bonds with each other, and with no fixed proportions and randomly distributed. These structures are called alloys. Contrast this with compounds between metals and non-metals, or between non-metallic elements, where the proportions of each element is fixed. The oldest example of an alloy, perhaps, is the way bronze took over from copper in the early human communities of Europe around 6,000 years ago. During the late Stone Age, axes began to be made of pure copper, but they were fairly soft. When small amounts of tin were added to make bronze, you got an axe which was twice as hard and worked well. The Bronze Age had arrived. The atoms in a metal lattice are held by non-directional bonds, a sort of sea of loose electrons, as we said, allowing the atoms to slide past each other, still touching, making metals relatively easy to melt and bend, but hard to vaporize. When metals change shape, atoms actually slip over each other like this. However, this process does not happen all at once, but bit by bit, rather like trying to move a carpet by putting a ruck in it. Here is the way it happens in a metal. You see the slip moving easily one atom at a time where there's a dislocation in the lattice. It is this easy movement of atoms in the crystal lattice that makes most pure metals soft. Now put a smaller or bigger atom into the lattice, and this easy movement of the dislocation is blocked. See the way the bigger atom stabilizes the dislocation, which gets no further unless you put greater force, meaning that it's harder to bend the alloy. To finish, let's look at some well-known alloys. Bronze, 3/4 copper, 1/4 tin, for sculptures, boat hardware, screws and grill work. Brass, 70% copper, 30% zinc, musical instruments, coins, door knockers. Carbon steel, 99% iron and up to 1% carbon for building construction, tools, car bodies, machinery, rails, etc. Stainless steel, iron with about 18% chromium and 8% nickel, used for tableware, cookware, surgical tools and so on. Aluminium alloys for planes contain a few percent of copper or other metals. Amalgam is mercury with silver and other metals once used for dental fillings. Solder, lead and tin for joining electrical wires and components, melts very easily. Gold is usually an alloy containing another metal such as silver for increasing hardness. The number of carats, K, defines how many mass parts of pure gold are found in 24 parts of the alloy.
Okay, so that video will have given you a quick overview on the various types of alloys that we're looking at and some of their different properties. So, as was said, pure metals are far too soft for most of our everyday uses, so we mix them with other metals to make alloys, and that's depicted in this diagram here. Alloys are harder than pure metals, and that is because of these larger atoms that prevent the layers from sliding past each other. They act as stabilisers, meaning that much more force is required to have that layer fully slide past and become ductile. Your first task is to copy and complete this table. I have put a version in Go for Schools if you would prefer to type it, or pause this video so that it's easier to see. On the next slide there is an information sheet that will help you fill this in, and I have also uploaded this to Go for Schools so that you can zoom in much easier. So this infographic shows the compositions of different alloys and will help you complete the table in task 1. I recommend pausing the video here and opening these two documents in Go for Schools so that you can zoom in and work on this much easier. Join us back in the video once you've completed that. So, now we know that bronze is an alloy of copper and tin, brass is an alloy of copper and zinc, gold is used in jewellery but is often an alloy with silver, copper or zinc, and that we measure the proportion of gold using carats. We also know that steels are alloys of iron with other metals or carbon. High carbon steel is extremely strong but quite brittle, whilst low carbon steel is much softer and more easily shaped. If we add chromium or nickel to steels, it makes them stainless and hard or resistant to corrosion, which we learnt about in our lesson on Friday. Aluminium alloys have a very low density, which makes them very useful for aircraft. Here is your final task. There are 9 questions for you to complete. I will upload these as a separate document to Go for Schools so it's much easier for you to read them. that is the end of today's video. Once again, I will be available on Teams if you need any help with anything.